This is the example of the Norton Theorem. Actually, the example is same as the Thevenin's theorem. Assume that we are trying to find the currents Ix flows through X ohm. First step will be remove RL. So this is RL. The RL is already removed. And then mark with terminals A and B. Step 2, you have to find the Rn. So Rn is equal to the R Thevenin's. Therefore, refers to the previous node, which is in the Thevenin theorem. In step 3, please find In flows from terminal A to B. So it means that you have to connect one line from the terminal A to terminal B. So this is In. There is only one method to find the In, which is the mesh analysis. You can see that there is a connection in between the nodes here and here. It is very difficult if you choose nodal in order to solve this question. So there is only one method that is suitable to find the In, which is the mesh analysis. Therefore, in order to solve this one, there is things that you have to apply in the circuit. I would like to show you on how to solve and determines the values of In using the mesh analysis. You have to remember the step for the mesh analysis. So first is determines the numbers of loop. Actually, in this circuit, if you see or in the circuit that consists of the R that can be in parallel, then you can parallel the resistor first. So this is the parallel resistor that already calculates in this circuit so that we can reduce the numbers of loop. Make sure that when you parallel some things, the question that being asked is not related to that R. As you can see that the question is need you to find the currents in here. So the resistor at the backs of the or at the left of the circuit, no, the right of the circuit can be simplified. So first is after you parallel the resistor, the 4 loop become 3 loops, and then identify the loop current, which is I1, I2 and I3. For the mesh, make sure that you remember that you have to do the KVL equations for each of the loop. And then please, before you continue with the KVL equation, you have to determine either the circuits consist of super mesh or not. As you can see that there is a current source in between the loop, so it means that this circuit consists of super mesh. This is super mesh. So let's start with the first KVL at loop 1. So KVL at loop 1, we start with the 5 volt. So minus 5 plus with 10 times with I1, which is I1 is flow through the 10 ohm. And then becomes, and then end with the 5 volt source. So, and then for the second and third loop, you can see that the loop is a mesh, super mesh. So you could have to combine the voltage at the loop 2 and at the loop 3. So 4I2 plus with the 4/3 times with I3 and then equal to 0. Because of the circuit consists of supermesh, therefore there is a supermesh equations that you need to determine, which is what is 3M in terms of I2 and I3. So I3 minus I2 is 3. Substitute this equation into the Cramer's or into the metric forms, and then you can calculate and determines the values of the I loop. So this is the answer for the first loop, which is 0.5M minus 0.75 for I2, and then I3 is equal to 2.25M. And you can see that in these circuits, IN is in between the I1 and I2, and you can see that the IN has a same direction with the I1. Therefore, I1 minus I2, and then the answer will be 1.25 M for the IN. The step number 4, the Norton equivalent circuit, you have to draw this circuit. This is very important. This is the Norton equivalent circuit. Next step, you have to insert the RL into the Norton equivalent circuit. So this is the RL, which is 8 ohm, and then you have to find the Ix that flow through the RL. Actually, you can solve and findings the Ix by using any method that you already learned previously. For this circuit, I'm using a current divider, which is you can see that this current divider is in parallel with RNs and RL. So IN is flow, and then it divided into RL and RN. Then you can use the current divider. This is the equations of the RN. So make sure that you remember the formula, which is if you want to know the I that flows through the RL, you have to use the other resistor that in parallel with the RL. Therefore, Rn is equal to the Ix is equal to Rn over Rn plus RL times with In, and then you can get this answer 0.3789, and then if you can see that the answer same as Thevenin's theorem and the previous method that you already done in the example and exercise. As I mentioned previously, this is the relationship in between Thevenin's and Norton's. The same as source transformations. Therefore, if the question asks you, after you already solved the Thevenin's or Norton, and then at the next question, it asks you, please draw the Norton's Thevenin circuit. And then what you can do is no need to do the step 1 until step 5. What you can do is we just convert from the Thevenin equivalent circuits to the Norton equivalent circuit by using the formula of source transformation. So V Thevenin to the IN. So IN is equal to V Thevenins over R Thevenins. And then if we want to convert from the Norton equivalent circuit to the Thevenin equivalent circuits, what you can do is you can use this formula, which is V Thevenin is IN times with the R N. And then the R Thevenin is equal to the R N.